Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Today, we are just going to see on the topic data frames. Dear friends, once you have seen the series, it's time to deal with the data frame, a more complex structured data. The data frames are very important since they are the central nucleus around which the whole Panda library revolves. It is therefore important to understand how they are structured within them and learn how to correctly define them within the Python code. But before we begin, we want to let you know that we have divided this exact data frame session into 3 parts, each covering a specific aspect of topic. So by subscribing to our channel, you will never miss any updates and get notified of our latest videos and series. Now let me just go into the data frame. Dear friends, a data frame is a more complex data structure than the series, and it can be considered in simple terms as the extension in two-dimensional of the structure of a series. So starting from the series that is now familiar to us, we can therefore think of the data frame as a set of series of the same length and all having the same array index in common and unified in a column to form a table. So kindly have a look of it. So here we are just going to define a series. Let I just give some values for the series. So this is the 1 and series 2. I'm just going to give some negative values 2 and 0 and a 4, and yes, 3 is another series. So here I'm just going to give 5 1 1 minus 3. And kindly just have a note of it, dear friends. Yeah, when on combining this exact series, yeah, with an index of the column. So in this, I'm just going to give something indexed to be as like A, B, C, D. So this gives us to that of data frame. So how the data frame is going to be? So kindly just have a note of it. This is what my index, and here it is my row. So let I just give the column as like in uppercase to be get it differentiated. So yeah, actually here we are just having only the 3 series. So let I just give 1 3 5 and 4 minus 1 1 and minus 2 0 1. So 3 4 minus 3. So this is what the data frame is. But in additional to this useful simplification, we need to add an additional array of the label that is called the column. Here I have just added 8. So this array will have the length equal to the number of columns inserted into the data frame, and each element will correspond to certain column equal to the real index. So let me just start with a data frame. And here, dear friends, there are 2 different types of indexing that works simultaneously. That is index for the rows and the tables of the values and columns for the columns. Okay, so let me just start with the data frame constructors. Okay, so kindly just have a note of it. So similar to the series, the Panda libraries provides a data frame constructor that allows you to define the data frame. So let I just import Pandas and let I just include the NumPy 2. Okay, so let's just start with the first one. So see here, dear friends, this data frame constructors that allows you to define the data frame object starting from a series of an input values. So here I'm just going to give it. Let me just have the data frame 1 here. I'm just going to give data frame, and kindly just have a note of it, dear friends. What is the syntax? The D is in uppercase and F is in uppercase. Okay, so here I'm just going to give the input in a series, and how I'm just going to give is 1 comma 2 comma 3. it is one nested here, and 5, 4, 5, 6, and then to the last here I'm just going to give 7, 8, 9. So let this be our example, and kindly just have a note of it. This is our data frame 1, how it seems. So as you can see, by passing only the internal values, the data frame constructor is able to autonomously populate the two vector index and column. And it does so by inserting a sequence of integer from 1 to n minus 1. That is what here in the row side we are just able to see. And here the n is the length of the index and columns respectively. If instead we want to have a data frame with all the label values defined in both columns and index, yeah, then we must specify them directly in the argument as an argument of the constructor. So kindly just have a note of it. How we are just going to see it here is, so let I just name this as data frame 2, and here I'm just going to enhance this by adding an index. So let I just give it in the next line to make you clear. So this is my index, and kindly just see I'm just going to make it by alpha. And of course I'm just going to give the columns also. So to differentiate, I'm just giving it in the uppercase, and kindly just note the output. It is df2. And now we have the index and column array enhanced by the labels. To be able to access these values directly, you can call the attributes as index and columns also. So how this happens is directly by the index. So this is what the index of it. So it's A, B, C. That's kindly just have a note of it. The index, it is in the lower case. And if you want to know what is the column, and here it is in the uppercase. So both attributes returns the data type. Kindly just observe the data type. The return type is object of the type labels. And however, if we want to have only the values contained in the data frame, yeah, we can just recall it only by the values without that index or the column. So here we just go that let we have df2 dot values. So let we just print what is there in V, and kindly just have a note of it. I just want to know only the type of V also. So here the attribute returns a two-dimensional NumPy array. Okay, this is how you can just get it done by the Pandas, that is the data frames. And kindly just have a note of it, dear friends. There is an other constructor arguments also there. So as we have seen in the series, yeah, kindly just have a note of it. This is the Pandas, and here I'm just going to give the data frame, and kindly just have a note of it. One is the data. The second one, yeah, we have just given the index, and yeah, we have also came to know about the columns and the D type. Lastly, copy. And we can see that the argument that the constructor accepts are the same as those of the series constructor, except the additional presence, that's the column argument. The series did not need this argument since the column are not present in that data structure. As for the rest, the same features may be previously applied. Okay, with the data type, this D type argument, it is possible to force the conversion of the type of the data passed as value. For example, if we want the values within the data frame to be a floating data, okay, so it will be necessary to add this type of to the D type argument. So let me just have, how come this can be done? So kindly just have a note of it. let I take the same thing here and to this new cell. So here I'm just going to add the D type, and here I'm just going to provide, kindly just, it is float 64. And once for all, let me just go with the print. It is df. Let I just give a different variable to get it differentiated. So here it is df3. So kindly just see here. As we can see from the result, even though the values passed into the data frame are all integer, the constructor has converted them to float point. Okay, so the copy argument is implicitly set to false within the constructor. So we don't explicitly specify it as an argument. And here we actually here we use a two-dimensional that is n-dimensional array to value the data frame. We will make a pass by reference. That is, the value will not be copied, but it will be the n-dimensional array passed as an argument to be incorporated within the data frame. If we modify the n-dimensional array externally by modifying a value, we will modify the corresponding value in the data frame at the same time, and vice versa. So let me just see it by an example. So kindly have a note of it. So this is an n-dimensional array. I'm just going to make it with an array type, and here let I just give the same value. So this is what my value. So this is what my n-dimensional array. So let I just have the different data frame. So pd.dataFrame, and kindly just have a note of it. The first attribute, it is all about the data. So I'm just going to pass that n-dimensional array, and next let I just go with the index, and yeah, here we can just make it any of the things. So A, B and C. Next I just go with the columns. So here I'm just going to pass it as let me just have A and uppercase B and upper C. Okay, now let me print the output of data frame 4. So kindly just have a note of it. So now if I just do any changes in an n-dimensional array, as here we are just discussing on to the functional on copy, okay, related to the copy argument. So kindly just see here, this n-dimensional array here, for the first index, I'm just going to change it as some other different, as like 4, 0, 6. Okay, 4, 0, 6. Now, if I just want to go with an NDA, so that n-dimensional array. So see here, this exact one, it was changed. Okay, it was changed. Now let we print the df4. So see here, it has changed. So in this manner, if I'm just going to give this df4, kindly just see here, I'm just going to make copy is equal to true, and now let I just print the df4 here. So it is already converted 406, and now I'm just going to purposely convert NDA of something. Let I just go with some other rows. Let I move on to this one. Gives us 1, 1, 1. So now if I just print the NDA, so see here, the last row has been converted, but what happened in the print of data frame 4? So see here, it is not converted. So if you do not pay attention to the exclusive use of one of this variable, yeah, of course, it is not a well-desired strategy. So your risk finding values modified without being aware of them, and thus making the unexpected errors during the analysis of the variables data. And here I just want to add one thing. Why is the parsing by reference preferred by default? See, data frames tend to be large objects that occupy large memory space. The same is true for n-dimensional array passed as an argument to the constructor. So in this case, we are carrying out the passage by reference means saving a lot of memory space by avoiding unnecessary operations. So here, of course, we have just done it. And yeah, as we can see the result, preceding result, now the data frame is completely independent from the n-dimensional array used to value 8. Okay, dear friends, here we just stop our part 1. Yeah, if you want to take your learning to the next level and join us on the exciting journey, don't forget to hit the subscribe button and turn on the notification bell. Let's see you on the next part 2 of this session. Thank you, dear friends. Happy learning.